Hey, and welcome back to our slides. Our slides give you some written examples of what we're working through at the command line, so it's always good to work through both. But here we're looking at setting up key-based authentication for our SSH client. Now, I'm sure this is covered in another course elsewhere, but there's nothing stopping us going over it again and making sure that we're really clear on how this is set up. We're going to be using the SSH keygen to create client key pairs. We're going to be copying the public key to the remote system. And then we can use the SSH agent and the SSH add command to cache our passphrases. Now, when we look at configuring this, we can use SSH keygen. We don't have to use arguments, but we can also use arguments to specify extra options, such as the type of key and any comment we might want to add to it. We can copy the key to the remote system. We can copy over the network, such as we're doing here, but obviously we need to use password-based authentication because key-based authentication won't be set up. We're in the process of copying the user's public key to the remote system so we can use it for authentication. If we've used a passphrase to protect our private key, and really we should, rather than having to put our passphrase in every time, which is going to be really annoying, we can go through and start up the SSH agent. With the SSH agent running, we're able then to read into our current shell its process ID and then add to that our passphrases. Once we've set all of this up, we're going to be able to have clean and easy access through to our system. And obviously, this is what we want to be able to see. We're going to make sure that we've got both Ubuntu 1 and Ubuntu 2 up and running. We've already configured password-based authentication for Ubuntu 2. But we're now going to generate our public key and private key pair on Ubuntu 1. We're going to copy the keys to the remote server, Ubuntu 2. We're going to set up our SSH agent to cache our keys. And then once we've set up our key-based authentication, we can disable password-based authentication on Ubuntu 2, keeping it more secure so we can only authenticate by something we have rather than something we know or, with passwords, can guess. Come on, let's go through and find that command line. Now, we do have Ubuntu 1 and Ubuntu 2 up and running, but we're going to start by working on Ubuntu 1, our SSH client, and we're going to connect in as the Tux user, the user that we created previously on our Ubuntu 2 system. We're going to begin by using password-based authentication, but if we take a look at what we have currently in our .ssh directory, we have the authorized _keys file, and it's this file that we're going to be looking to create on our remote system as the Tux user. This then says the keys that are authorized to log in as from our client systems. It's there on Vagrant by default because we log in from our host system as the Vagrant user using an SSH key, but it's hidden and made transparent to us. But let's look at how we can transparently log in as Tux on our remote system. To begin with, we must go ahead and use the SSH keygen. We can use this without options, but we can put options such as the type of key we want to create, and we even have tab completion showing the types of keys that are supported. I'm going to use the default RSA key pair, so we can be creating a public key and a private key pair based around the RSA algorithms. We can accept the default path, and now we're being prompted for a passphrase. If we don't put on a passphrase, we are not securing the private key. It's the passphrase that makes the private key secure. Without it being secure, anyone who has access to our private key can use it. So a passphrase is definitely required. So we're going to add in our passphrase, make sure that we can type the same passphrase twice, and now we are up and running. If we go back and list then our .ssh directory, We've got our private key, ID_RSA, and the public key, and it's the public key that we must copy to the remote systems, and it's that we're going to use as part of our authentication. We don't copy the private key. We can use SSH copy-ID. Where we have more than one public key, we could use the option -I to specify the public key to copy. We don't need that, so we can leave it blank. And then we need to copy it to the Tux user account, the user Tux, on the remote system. And I'm going to put, of course, the IP address of my Ubuntu 2 system, but you put in your IP address, the IP address of your Ubuntu 2 system. But once we're done on that, we can hit enter. It's the first time we've connected, so we need to pick up the public key from the Ubuntu 2 server. And of course, we're using password-based authentication because as yet, we're only in the process of setting up our key-based authentication. So we need to put in the Tux user's password. You should have created this with the user when we set it up. But with that done and dusted, it now then shows me what I can do to log in as the Tux user on the remote Ubuntu 2 system. I can go through and copy it. I don't really need those single quotes, but they won't harm. But you can see now that I have to put in the passphrase, that we use to protect our private key. And at this stage, we might think, well, we've not really gained anything, especially if we can't get the passphrase correct. Oh, let's try it again. Aha, we're in. But as I say, we do want that passphrase to protect it, but we're going to look at how we can secure it. But you can see now that I'm the Tux user on the Ubuntu 2 system, so we've gained access and we've been able to use our public key and private key pair as our authentication mechanism. If I go through and take a look on the Tux user's home directory, .ssh and authorized key, we can see the key that's been copied up. Now, obviously, this is the Tux account. It's not the same Vagrant account that we log on from our host systems. But if it was the Vagrant account, we would be appending to those authorized key. But this is a brand new account that we've just created. But we can see now that we've added in the Vagrant user's key from Ubuntu 1 into the authorized key file. But let's exit back now to our Ubuntu 1 system and concentrate on how we can automate the process a little bit by caching our passphrase. If we go through and look at the output of a command using eval, and then we're going to open up our subshell, and we're going to run the SSH-agent. The agent then can be used to cache the passphrase, and we can see then the process ID that's being reported. That process ID is monitoring for this shell, and if I go through and look at PS-F, a full listing for the process ID 1643, we can see the process is owned by me, the Vagrant user. The parent process ID is systemd, process ID 1, and it's running to monitor my current shell. It works for this shell, but not other shells. If I needed to persist this, I could add it through into my login script. We can add in the passphrase. So we're now having it cached by the SSH-agent. And now as I go through, I can connect seamlessly straight through to my Ubuntu 2 system. We can check the prompt. It is Tux at Ubuntu 2. But now we've set this up, I'm going to switch across to the Vagrant account. The password for the Vagrant account is Vagrant. Vagrant then has access to sudo, and I can edit the configuration file of my SSH daemon. Obviously, as the Tux user, we didn't give any additional privileges, so we have to do this as a Vagrant user. We want to now disable our password-based authentication. Let's move down, search for password, move to the end of the line and change this to no. Save our changes. Now that we've set up our key-based authentication, we can secure our system by not allowing password-based authentication. It's going to make it more easy to manage and more simple because we don't have to put passwords in. We can restart our SSH daemon, and with that done, we can exit back to Tux, exit back to Ubuntu One, and we are done and dusted. We've set up our key-based authentication, and we've successfully disabled password-based authentication on the remote system.